Alright, and welcome to 15.2 review. Today I'm going to do a couple random problems that didn't really fit into the first 2 days, but I'll also be doing problems where we have to go from the radical to the fractional exponent and vice versa. Alright, so we're just going to start on number 1 here. Okay, so you have two options really when you start a problem. You can work it as is, or you can change it to a different form. So if you want to change this to radical form, you could do that. But if you ever have the same base and you're multiplying or dividing, don't forget we have exponent rules. So these have both a base of 12. I'm allowed to just add those exponents. So I'm literally going to say 12 to the negative 1/2 plus 5/2. I'm just going to add those two together, okay, which is going to be 12, and then 5 minus 1 is 4, so to the 4/2. 12 to the 4/2 is 12 squared, and 12 squared is 144. So that is your final answer. That one did not require any changing exponent to radical, whatever. If you have the same base and it's multiplying or dividing, you can just straight up add or subtract. So going over here to the second one, I see that I have the exact same base and different exponents, but I am dividing, so I'm actually going to subtract. So make sure when you do it, though, that you take that entire base, that negative 4. And then it's going to be 4/3 minus 1/3, which is going to be a negative 4 to the 3/3, and then negative 4 to the 3/3. Same thing as saying negative 4 to the first, which is just a negative 4. So no need to change those exponents. Okay, our next problem. Again, I have this same base. I have 6 to the 4/3, 6 to the 1/3, and a 6 to the understood first power. So they are all the same base, but I do have a mixture of multiplying and dividing. So I'm going to go ahead and just do the top part first. So that's going to end up being, and I'm not going to write the addition out. Actually, yeah, I will. Actually, because I need to change that 1 to a 3/3. That way I can have the same denominator, and then 6 to the 1/3. So I just added 4/3 plus 1, which is 4/3 plus 3/3. So that's going to be 6 to the 7/3 on top, and then 6 to the 1/3 stays on bottom. So all I did was I had the same base, I multiplied, so I just added exponents, but I needed to use a fraction. But you could just type it in the calculator if you have one. Alright, now I have division with the same base, so I'm going to say 6 to the 7/3 minus 1/3 is going to be 6 to the 6/3, because 7 minus 1 is 6. 6/3 is the same thing as saying 2, and 6 squared is the same thing as 36. So that final answer is 36. Alright, moving over. This looks very similar. You would think same base, just add exponents, but this guy is not multiplication or division. He is addition. You can only do the adding and subtracting if you're multiplying or if you're dividing. If you're adding, you treat this guy entirely separate and this guy entirely separate. So I'm going to go ahead and do 8 to the 2/3. Well, I don't know what that means currently. I mean, if you don't know what that means, then change forms. Well, that means it's 8 squared, but then that bottom number, remember, is your index. So it's the cube root of 8 squared, or you could write it as the cube root of 8 squared. Really just depends on how you want to do it. I'm actually going to go with this method because cube root of 8 is a perfect number, whereas here I need to have a 64 and then cube root that. That's just less work. But either way works. I just want to do it this way. Okay, then I'm going to do the same sort of thing on the other one. I could do 8 to the negative second, and I could do cube root. Again, this is the power, this is the index, but I'm also going to do the cube root of 8 and raise that to the negative second power. So you really could do it either way, but I prefer to put my exponent on the outside, especially if my inside numbers are perfect. Alright, so cube root of 8. Cube root of 8 is, how do you get 8? Well, that's 2 times 2 times 2. So I'm looking for groups of size 3. So the cube root of 8 is 2. But don't forget that that entire thing is squared. So I just, cube root of 8 is 2. But the whole thing is still squared. Plus, cube root of 8 is still going to be 2, but that's raised to the negative second power. Well, 2 squared is 4. 2 to the negative second power, don't forget when you have negative exponents, you take it downstairs. That's going to be 1/2 squared. So that's 4 plus 1/4, which makes it 4 and 1/4, or 4.25, or whatever you want to write. It's fine, but that guy is 4 1/4. So just to review these guys real quick, you can only add exponents or subtract them if you're multiplying or dividing. If you're adding or subtracting, you just legit do each thing separately. And there's several ways to do it, but if you end up with something that's going to be a perfect cube or a perfect square, I would put your exponent on the outside so you're going to save yourself from work. If you had to do the cube root of 64, you still would have gotten 4, because 4 times 4 is 16, times 4 is 64. You would have gotten the exact same answer of 4 and the exact same answer of 1/4, but just whatever path you decide to take. All right, number 5 is similar to number 4 in the fact that it is a subtraction problem. Also, these bases are not the same, so hopefully you wouldn't be tempted to add exponents anyway. So 25 to the 1/2 power, what does that even mean? Well, that really means the 2 is my index. So I'm going to do the square root of 25 to the first power on the inside or the outside, doesn't really matter. Okay, minus 16 to the, and this is going to be my index, to the 4th root. So 16, and then that 1 power goes on the inside or outside. But again, it's a 1, so who really cares? All right, square root of 25 is 5. Hopefully you know that, but also 5 times 5, looking for groups of size 2. So that's a 5. Minus, well, 16 is 4 times 4. 4 is 2 and 2 and 2 and 2. So the 4th root of 16 is 2. So that entire answer becomes 2. So 5 minus 2 is 3. All right, moving on over. This one, so there's no addition or subtraction or division or whatever. This is just straight up something raised to a power. So there's several ways to do this. So I'm just going to show you the way that I always work these problems out. So I like to, if I have a number and a variable, I like to do them separately, just because, especially if they're not going to work out perfectly. So I'm going to raise this negative 27 to the 2/3 power and this x squared to the 2/3 power. So I'm going to deal with my number and my variable separately. All right, so this guy, what am I going to do with this? Well, I don't know what negative 27 to 2/3 power is currently, so I'm going to go ahead and put negative 27 on the inside, and I'm going to do the cube root of that. And if you know that negative 27 has a perfect cube, then put this squared on the outside. I do know that 27 is 3 times 3 times 3, so I'm going to go ahead and put the squared on the outside. If you needed to put on the inside to make a higher number, then go for it, but this works. Okay? Then over here, when you have power to a power, you multiply. So this is actually going to be x, and then 2 over 1 times 2 over 3 is 4/3. And there's a couple ways you could do this, but I think it's easier just to multiply so that you have a nice power. All right, well, the cube root of negative 27, that's negative 3 times negative 3 times negative 3. So the cube root of negative 27 is negative 3. So this entire answer becomes negative 3, but it's still going to be squared. All right, well, x to the 4/3 power, what does that mean? I don't know. That means that I have a cube root of, and my base is x. Now, it doesn't make any sense to put the 4 on the outside here because I don't have enough x's on the inside. So whenever you do variables, you always want to put that variable exponent on the inside so that you can do that math on the inside. All right, so we're still, these things are still touching each other. I'm just doing them separately. Negative 3 squared is 9. The cube root of x to the 4th. Don't forget, when you're doing variables, you say 3 goes into 4 how many times? If I was to write this out, I'd have 4 x's. Looking for groups of size 3, I can take out 1 whole x, leaving me 1 x left over. 3 goes into 4 1 whole time with 1 remainder. My final answer is just 9x and then cube root of x. All right, our next problem has a multiplication. You could do this a couple of different ways. Again, you just really have to decide what you want to do. But I do see that they have the exact same base. So this goes back to our original problems where if you have the same base and you're multiplying, you can just add exponents. So my same base is the 4th root of 3x, and all of that is now going to be 2 plus 2, which is to the 4th power. From here, you could do a couple different things. You could bring this 4 on the inside and have 3 to the 4th and x to the 4th, if that was helpful. But actually, in this case, because I'm doing a fourth root and I'm raising it to the fourth power, those things actually cancel each other out. My answer is 3x, but I do have time. In case you don't see that, I'm going to go ahead and show you how to do it the other way. Okay, so currently I can't do fourth root of 3 and I can't do fourth root of x to the 4, like just x. I can't do anything as is. So I would have to pull that fourth exponent on the inside, and it'd have to go to everybody. Then if you actually wanted to multiply this out, you could, but then you'd break it back down. You go, oh, well that means I have 4 3s and I have 4 x's. Looking for groups of size 4, I'd pull out a 3x. So really, no matter how you do it, you get a 3x, obviously. But if you can ever see the same base, that just really makes it much easier. All right, and our last problem here. Again, I could take this 2 really inside or outside, wherever you want to, but this 2 is touching the 4 and the x. So currently what I have is I have 4 squared and I have x squared. Well, I can't do anything just yet. I don't have enough 4s if I were to write this out. Cube root, I have 4, 4, and x, x, if I'm multiplying it out. I don't have enough of anybody to pull any groups out. So that's not going to work currently as is. So I guess I probably could have done it from here, but oh well. So I'm actually going to go ahead and multiply this out. So 4 squared is 16. Well, break down 16. Obviously, we know it's 4 and 4. I could have left it like that. But 4 is 2 and 2, and 4 is 2 and 2. So I've broken this down. I could have broken it down here into 2 and 2 and 2 and 2. But either way, I now have 4 2s. So I do have a group of size 3. So I can go ahead and take out that 2. I do not have enough x's to take out. So those guys are stuck inside, and so is this 2. So cube root 2 is left on the inside, and so is that x squared, and there's no one else to take out. There's really not another way to solve that one. I mean, I guess you could try a couple of different things, but that was kind of the trick way to solve that. All right, so we are done, and that means that your homework is on Canvas, so go ahead and answer those few problems. All right, bye.